Objective 3 in section 1.8 is to combine like terms. And you can think of combining like terms as a reverse of the distributive property. So in this first example, both of our terms already have their b's. Well, that distribution truck could also go around at the end of the day, at the end of its route, and pick up all of the empty trays and bring them back to the distribution center. So combining like terms is that we use distributive property in reverse to add or subtract like terms together. So let me do some examples of that. In this first problem, we have 13 b's and we're taking away 4 b's. So I could take the b back off of each of these terms and put it back out in the front, so I would end up with a b and a 13 minus 4, or b times 9, which as you've seen before we usually write as 9b. Many of you may remember doing this from a previous class and may just combine these like terms without going through all of these steps. That's absolutely fine. Okay? So if writing down the steps helps you do it, it's okay to write them down. If you just want to look at it in your head and say, well, 13 baseballs, take away 4 baseballs is going to leave me with 9 baseballs, it's fine to go straight to that step without going through all of these extra steps. Looking at the next problem, I have 2 terms that have d's. Notice that when I underline it, I'm taking the sign with the term. And I have 2 terms that are just constants. So if I rearrange this problem a little bit, associative property says as long as I take the sign with it, because this is really plus a -1 and plus a -8, I can use the commutative property to put these in a different order. So I'd end up with a d plus a 5d minus an 8 minus a 1. Combining these 2 terms together, remember that there is an invisible 1 in front of that d. It's always okay, because of the multiplicative identity, to multiply something times 1. So 1d plus 5 more d's gives me a total of 6 d's. And if I have already taken 8 away and then take 1 more away, I'm going to end up with a -9. And that is our final simplification of this expression. We don't have a way of getting to the answer because they haven't told us how much b and d are valued. Let's look at a couple more examples. In this problem, all of my terms have w's, but only these 2 terms have a w that is cubed. So I can combine those 2 terms together, 9w cubed minus, I'm going to put the invisible 1 in there, 1w cubed, and then I have 4 more w's still to use. So 9w cubes take away 1 is going to leave me with 8w cubes, and then 4w. And there is not a way to get the w's to go away completely because these 2 terms cannot be combined. Looking at this next problem, I'm going to use the distributive property a little bit before I try to combine my terms. So remember, the distributive property is that detour that lets us bypass parentheses and go straight to multiplication. So by distributing the 2 onto the 8f and onto the -1, I end up with 16f's minus 2 minus 4f's plus 7. So I have 2 terms with an f on them, a positive 16f. Notice again the negative comes with this term, and then 2 constant terms, a -2 and a +7. So my 16 F's take away 4 F's is going to leave me with 12 F's. And my negative 2 plus 7 is going to leave me with a plus 5. One final example in this section has the distributive property being used twice. First to distribute the 5 onto the 3n and the 2, and then to distribute the negative onto both of these terms. So 5 times 3n would give me 15n. 5 times 2 would give me a plus 10. I'll put the invisible 1 in there again. A negative 1 times a negative 4n is going to give me a positive 4n. And a negative 1 times a positive 8 would give me a negative 8. Now that my grouping symbols are gone, I can look for terms that match. And I have a 15n here and a positive 4n there, a positive 10 here, a negative 8 there. So 15n plus 4 n's would give me a total of 19 n's. And my plus 10 minus 8 leaves me with a plus 2.